Assalamu alaikum wa rahmatullahi wa barakatuh. I greet you all at whatever time you will be watching this, either in the morning, in the afternoon, in the evening, or late in the night. And I pray that everyone is keeping safe and you're protecting yourselves from the current situation of the pandemic. So, as I told you in our Zoom class, that we shall be having recorded video tutorials that will take us through most of the practical part of our course unit. So here we are with our first recording that is going to introduce us to the database programming environment and the SQL language, basically. Then we shall look at how to create a database and a few things about database before we can get deep into the practices. My name is Mr. Olsimbi Abdul Hakim, just a reminder. Some of you might have forgotten. And I'm here to take you through this. Okay, so database programming. As I told you that any information system, as IT students, we are basically dealing with information systems. And information systems have basically three components: the database level, where all the data that is generated by the information system is stored, and then the back end, which does the logic and the functionality of the system, and then the front end, that is the part which the users of our system see or what they interact with on the system. So basically now here we are looking at the database level. How do we manage the data of an information system at the database level? So an introduction, you're saying that most of the business software systems, they depend on the database, as I've told you that all information systems, because we can have some other software that don't depend on database, but if it is an information system, then as a must, it depends on a database. They're saying that database management systems like MySQL, as I told you, we have different servers, as we shall say again. MySQL is one of these database management systems that help us to have capabilities to create and manage databases. So MySQL provide the database storage and querying capabilities that is not available in many other systems. As we shall see the ranking why we chose MySQL, it has a better reputation than other servers. And so we're saying that also today's modern database management systems support advanced programmability to the extent that entire system can be built fully at the database layer. This means that with the capability of advanced programming that these database management systems provide us, we may not need the other levels. We may not need the back end. We may not need the front end, whereby you can do all the programming at the database layer, and probably all we need was maybe just the interface, but the back end might be ignored. So we only need the interface that the users will interact with on our system. So it provides us with this capability, and that's what we are going to be looking at. That is the programming part of the database. Okay, these are the learning outcomes. Shall be able to create and manipulate data structures like tables, views, functions, stored procedures, and many other things. And then also to be able to insert and manipulate the data in a given table, to perform ad hoc, we can say required queries, to perform required queries on a single or multiple tables based on the established data requirements, depending on what we need, which kind of data do we need. So we shall learn how do we create a query to return to us the kind of results that we need. Okay, for example, you have a table of students, but you just want to see a list of students that are doing BIT. Okay, so how can you create a query that returns only that data of interest that we need? And then the other one is create programs. Mostly they are stored procedures or functions that perform additional computation and data manipulation operations, as we shall see later on in the course. How do we create stored procedures and functions and some other objects? Then build interfaces for user database interaction. As I told you, with the programming capability that this database management system provides us, we may not need the back-end layer, and all we need is to create an interface. Because why the interface? Why the front end? Because the users don't want to see the codes. They don't want to see the data work that we do. So for them, we just build for them beautiful interfaces that they interact with. When you interact with the ERP, you just see a nice looking interface. But behind that nice looking interface, there is some data works, the lanes of instructions that are behind it to implement the functionality that we appreciate. So if you have the stored procedures and all these things that we have created in our database, so mostly if we need our users to interact with our database, then we shall need to build some interfaces. This will depend on how fast we shall move with these required things, because this is the core part. So if we get time, then we shall create some interfaces, and we see how from the user end, how can the user interact with our database objects. So as I told you, most of the database management systems are based on the SQL language, that is the structured query language. Last time I was confusing whether it is structured or sequential, but it is structured query language. Majority of these database systems are based on this, so it is important that we first pay attention on some of the few things of this SQL language. So you're saying that is a programming language specifically designed to work with databases. You cannot find SQL to work with back-end or creating front-end. No, it is basically for the database. It allows you to create, manipulate, and share data, specifically data from relational database management systems. I believe from Mr. Kasaga's class, you learned about what is a relational database. Basically, what it means is these are databases whose components are related. What you mean by related? They share information. For example, you have a table course and you have a table student, but a student, among the information of a student, we have a course. So meaning that if student shares information about a course, and course is the table on its own, it means that these two tables, course and student, are related. Okay, so that's what we mean by relational database. So we have to create that relationship through what we call as a foreign key, and then we establish such. So we are saying that SQL is most used in relational databases. Nowadays, non-relational databases are also gaining popularity, and basically they are using what we call as NoSQL. What we mean by NoSQL, they don't use the SQL language. Although some of them use SQL, yet they are not relational databases. So MySQL is a relational database, and that's what you're going to be looking at. We are not going to be looking at the non-relational databases. Then SQL allows you to write queries that the database server can execute and then provide database insights in return. That is, it gives us the results that we intend through using the SQL language. So we are saying that there are many RDBMS, relational database management systems, that support such original versions of SQL, and there are slight differences. So each of these servers has some unique features of the SQL language that you may not find in another server. So for example, what you may find in MySQL, you might find some few things in MySQL that you may not find in Oracle. And the reverse is true. You have something in Oracle that you will not find in SQL, but those are minor things. They are not major. But the major things, the major components of SQL, you find that all these database servers, they share them. For example, if I want to create a table, so the syntax I use to create a table is the same syntax the syntax I use in MySQL to create a table. You find that it is the same syntax I'll use in Oracle, in Microsoft Server, SQL Server, in Postgres, and all these other database servers that are listed here. Then the keywords, you should by now appreciate that the programming languages that you have learned so far, that is the C and the Python, each is made up of a keyword or a list of keywords that are reserved for a particular meaning. So likewise, SQL also has its own reserved words, which are the keywords. So these are reserved words. They cannot be used. We cannot use them for other. So we cannot create our variable and we name it as int or as maybe double or float, because float, int, double, these are keywords in this language, so we cannot use them to name other things. That's why they are reserved. So the keywords of the SQL language, now this is the important part here, is that the keywords in this language are case insensitive. In the previous two programming languages that you have looked at, the C and the Python, we have been saying that keywords are case sensitive, meaning that if you're writing int with capital I and int with small I, the two are treated differently. So whereby the keyword is all small case, but if you try to write a capital letter in a keyword, it will deny it. So now this is not the case in SQL. SQL doesn't mind the casing of the keyword. Whether you write in uppercase or lowercase, it will accept both. It won't return an error. It won't raise an error. So if you want to use keywords, I mean uppercase, with your keywords, go ahead. Even if you mix letters, for example, I'm writing int. I start with I, then small n and capital T. That will be fine with SQL. I can choose to write int throughout capital letters or int throughout small letters. So that is what we mean by case insensitive. It is not sensitive about the cases of the letters of the keyword. So especially for me, as I'll be writing my code, I'm going to be sticking to using uppercase for the keywords, so that I make them stand out that, okay, this is a keyword. Yes, in addition to changing the color that SQL provide us, or the MySQL provide us, I also make them capital letter so that they can stand out. But for you, as you're following, you can choose. I advise you follow with me. It is a good idea. It is a good thing to do, that you write your keywords as capital letters. It helps in the readability of your code. So if you mind about the readability, then you can follow along with me and get used to that. But if you don't, then you can just maintain the same casing for all your queries. Okay, then after looking at the SQL keyword, then the syntax of the SQL. The syntax, remember, I can remind you that the syntax, these are the rules that govern a given programming language. The set of rules that govern a given programming language say that you can write statements that are considered to be valid. That is what we mean by syntax. So when you follow those rules, you create a statement, and that statement is considered valid in that it doesn't return an error. So the moment you get an error in a statement, it means that you have broken one of the syntax rules of that language. And you're saying that the syntax is basically composed of these three components. We have the data definition language. We are going to see them in details one by one. Data manipulation language, data control language, and transaction control language. So these are the components. One statement could be composed of more than one of these, or all of them, but most of the times just one or two or three. Okay, the same syntax having some of these things, but most of the times you find that it's only one statement that has either a data definition or a manipulation or a control or a transaction. So let us see the details. So data definition. So by the statement data definition language, it means that every time you want to define a set of data or maybe an object, then that's when we use the DDL. So a set of statements that allow the user to define. So here the user, we are referring to the programmer, because we are going to be creating these things. So we are the programmers of the SQL, but you're writing again programs for other users. So don't be confused with the user here. So the user here, we are meaning we, the programmers. A set of statements that allow the programmer to define or modify data structures and objects such as tables. So every time maybe I want to create a table, I want to create a database, I want to create a view, I want to create a function, a stored procedure. So I use data definition language, as you're going to see. So this include most of the times the create statement. The create statement is a core DDL word that we most of the times use to create objects. So used for creating databases and other objects like tables, functions, as we shall be seeing. and then the outer statement. So as for create, it creates something new. It creates a new database, it creates a new table, it creates a new function. Then for the outer, it helps us to change an existing object. Okay, you already have your table created, but you want to make some changes in it. So we use the outer. You've already created your function, but you want to make some changes to in it, then we use the outer statement. So it's like, okay, it changes the definition of an existing table. Then rename, that is in case you want to change the name of an object. You have given a table name as maybe courses, but you prefer to name it as course table. Okay, so in case you want to change the name of the object, use the rename statement for the DDL. And then drop, for drop is in case you want to delete this object. I want to delete the database, I want to delete the table, I want to delete a function, so we use the drop statement. And then the truncate, this truncate, we shall understand it more when we start looking at tables and inserting data into the table, and now we want to remove the data. So it is like deleting the existing records of a given object, and it has a way, it slight difference with the delete, and we shall look at it. So instead of deleting an entire table through drop, you can also remove its data and continue to have the table as an object in the database. So we shall see this one. For now, you may not understand it clearly why we need the truncate. So I want to keep these tutorials short so that they're not too lengthy. So I'm going to pause this one here, and I'm just going to proceed from here in the next tutorial.